Okay, this is a typical duplex receptacle. It's one of the square kind. We have both kinds. I'll show you the other ones too. I just wanted to show you how you wire these though. If you look, you will see that you have silver screws on one side. You have gold screws on the other. The ground is here and it is a green screw. So, here's how you wire these. You have a strip gauge on here. If you look right there, you will see where that strip gauge is. Now, white goes to silver, so this is the silver. So we're going to stick a white wire in here. We're going to tighten it down. These again are compression fittings, which are my favorite. I would much rather use these than I had the standard type. Now, this is the gold screw. So we're going to take the gold screw, and again we're going to strip this wire back according to the gauge. And we're just about perfect. So now we put this down inside of the gold screw and tighten it down. And now we have the hot and the neutral. Now if you want to continue this down the line, you have a second set, one here and one here. Now these will continue to the next receptacle if you have one. In this case we're not, because I'm simply showing you how to wire this up. Now we've got a green, so we've got to put a green wire on there too. So we're going to strip this back a little further because we've got to put a kink in this one, and we'll do it. This is not really the right way to do it, but I'll do it this way just so everybody can see. I'm not prepared for this tight, but this is what you have to do if you do not get the compressed tight. Now I always try, when I do these, I always try to put it on so that it is going, the end of the wire is in the direction that you are going to be turning the screw. If you don't, it tends to push out, and we do not want that. So, and now you see why I prefer the compression fittings, because this is really a hassle to do. No matter how you do it, it's always hard. I don't like them, but anyway, you hook it on like that, and if you look, the end of the wire is on this side and the screw turns that way. It will not push out if you do it that way. So, good and tight, give it a good tug. So now we have a black wire, which is the hot, we have a white wire, which is the neutral or return, and then we have a green, which is ground. And that's the proper way to wire one of these receptacles. Okay, now, like I said, if you have more than one, you come in with the hot, you go through, and it goes out, and it goes to the next one. All right, now it is connected right there. This little bar that goes across right there is what carries the power from here to here. And just as it looks, this is all in parallel. It's important that you put all these in parallel. The reason being, you want the same voltage at every location. Each one of these must have 110 volts. If you put them in series, it will drop that voltage across the first one and will not work for the rest because the voltage has already been dropped. That's what happens in a series circuit. In a parallel circuit, the voltage is the same on every cross piece. So that's what we've done. We've got the white wire and it goes to the silver. And again, there's a bar that takes it across. It goes to the next one, and then it goes all the way down to the load. And this would be similar to what you would see inside a house. Only you would have a lot more of these. So you would start out from the breaker. The breaker would be back here. Then you would go to the first duplex receptacle. These are called duplexes. Then you would go to the next duplex, and when you got finished with the duplexes, usually we will put a light switch on the end. Now, The hot is in series on the light switch. The white does not even stop there. It goes straight by, and so does the ground. We don't have a ground on this particular kind of light fixture, so this would normally be mounted onto a metal box and the ground would go to the metal box. I can't show you that here because we don't have it. So now let's put some power on this and see what we can find out. Okay, let's take a look at what we've got here. I have a system rigged up here, and it is hot. Do not do this at home. This is wired in parallel. It has to always be parallel. The black goes to the gold, then it continues to the next gold, then it continues to the next gold, and so on and so forth. And now we're going to look at the white. The white goes to the silver. Then it goes from the silver to the next silver. Then from the next silver it goes to the load. It does not go through the switch. And ground, of course, goes to pretty much everything. The reason the ground is not hooked up on this light fixture is this light fixture does not take a ground. It would typically be mounted to a metal box, and the metal box is where you would put the ground. So let's flip this back over and take some measurements. Okay, if I check here, if I take the red lead and put it here, and I'm set on AC on the meter, it's the little V with the wavy line above it, and I go from black to white, I get 122 volts. If I go from black to ground, I should also get 122. And I do, I get 122 volts to ground. Now, because we are in parallel, each and every one of these is 122 volts. That one's 122. That one's 122. That one's 122. And this one's 122. Now if I get on common back here, the white wire back here at the back, and I measure to the switch, on the incoming side I should get 122 volts, which I do. On the outgoing side, I do not. I got 1.3 volts, which is a residual. Now if I turn this switch on, the light comes on, and now I have 122 volts on both sides of the switch. So all the switch does is allows the 110 volts to pass from here to here. And by the way, do not try this at home. This is something you need experience to do. I have these exposed and they have live voltage on them, and it can hurt you or even kill you. So do not try this at home. I've been doing this for 50 years. When you've been doing it for 50 years, maybe you can do it too, but I would say right now, do not try this at home. So now, if I take and I plug something in, we're going to use a drill. Let's say, now this does not have a ground on it. Now you see there's a wide blade and a narrow blade. If I plug this into this one, it comes on. That means I've got 110 volts there. I unplug it from there and plug it into here. I also have 110 volts there. If I unplug it again and plug it here, I also have 110 volts. That's why it is so very, very important to keep these in parallel. If you goof up, the system will not work. So as you can see, each one of these plugs has 110 volts, and that is why, because we hooked it all up in parallel. Okay, we're going to look at one of the great mysteries of the universe now. We're going to look at the notorious three-way switch. These are industrial type, and they're a little stronger, a little more well built than the standard. Here's a standard. We can take a look at. This is what a standard looks like. It has a black screw and then 2 gold ones. The power goes to the odd color screw, and on these it's kind of a bronze color. On this it's a black. And then these 2 wires are called travelers. They go between the 2 switches. And as you can see, it goes from the gold to the gold on one side and the gold to the gold on the other. And then the final wire, it leaves the other brass or black screw, depending on which type you're using, and it goes to your light or whatever you would like to turn off and on. And the great thing about these is you can go to either one. If I flip it this way, as you can see, the light comes on. If I flip it back, the light goes off. If I flip this one, the light comes on, and then it goes off. Now, if I turn it on here, I can turn it off here, and vice versa. I can turn it back on here, and I can turn it back off there. So there is no on and off on a 3-way switch. Anyway, now that you've seen this, we can wire two 3-way switches. And next we'll look at a 4-way switch which goes in between these 2. We will look at that next. Okay, let's take a look at 4-way switch. In order to have a 4-way, you have to have 2 3-ways. So the power comes in on this end. It goes to the bronze screw. Then we go to the gold screws, and we have jumpers or travelers. They're called travelers. When you do this, you're probably going to use a 12-3 with ground, and you're going to have a black wire, a red wire, a white wire, and a green wire. Now on here, for this demonstration, we do not have the green wire or the white wire because we're doing this in DC for safety's sake. But if you look, the power comes in here, goes travelers from the 3-way to the 4-way. Then from the 4-way, it continues on, and it goes to the other 3-way, and then it goes to the light. This wire goes to the light, and common is made by the board that we built here. So normally you would have a white and a green wire with this. The greens would of course go to ground, and the white would go from the source to the light. That's pretty much it as far as the wiring is concerned. Now, the way this works is any light or any switch will turn the light on or off. So if I flip this one on, as you can see, the light comes on. If I flip this one, the light goes off. If I flip this one, it's back on. If I flip this one, it's off. If I flip that one, it's on, and that one, it's off. So any switch that